Hi friends, in this tutorial series, we'll be implementing examples using Spring Boot 3 and Elasticsearch 8. In this tutorial, we'll be performing CRUD operation on an Elasticsearch database using the Spring Boot application. Also, in further tutorials, we'll be modifying this example to implement pagination and make use of Spring Data Query. For this, I'll be taking reference of my website javanews.com. So go to Spring Boot Elasticsearch. In today's tutorial, we'll be implementing Spring Boot 3 Elasticsearch 8 CRUD example. So let us begin with the implementation part. In previous tutorial, we had implemented an example to set up Elasticsearch 8 with credentials. You can go through this example. So for this, we'll first need to go to the Elasticsearch downloads page. So here the current release of Elasticsearch is 18.13.4. Download this. This is the Spring Boot application that we'll be creating. So here using the REST controller, we'll be exposing some REST endpoints to the user. The user, he makes use of these REST endpoints to perform CRUD operation on the Elasticsearch database. So the user, he makes a call to these exposed REST endpoints. The controller then makes a call to the service where the business logic is written. The service makes use of the DAO layer to make the actual connection to the Elasticsearch database and perform the CRUD operations. So let us begin with the implementation part. In previous tutorial, we had implemented a tutorial to set up Elasticsearch 8 with credentials. So go to this tutorial here. In this tutorial, we had set up an Elasticsearch cluster, and also by default security is enabled for the Elasticsearch 8 cluster. So we need to set a password whenever we need to start this Elasticsearch 8 cluster. I have given this tutorial here. You can go through this. For this tutorial, again, we'll be setting up the Elasticsearch instance. So go to this Elasticsearch downloads page. So the current version of this Elasticsearch here is 8.13.4. Click on download. Here I've extracted the Elasticsearch installable that we just downloaded. So go to this folder, go to bin, and here we'll be starting Elasticsearch. So for this, I'll be starting the command prompt. So elasticsearch.bat. So this will start our Elasticsearch instance. So here the Elasticsearch 8 instance, it has started. With Elasticsearch 8, by default, security gets enabled. So here on startup, it enables Elasticsearch authentication. So here this is the auto-generated password that we'll need to use if we need to access this Elasticsearch instance. Also by default, HTTPS gets enabled for this Elasticsearch instance. So if you go to this location, HTTPS localhost 9200, advanced, proceed. So here it is asking for credentials. So by default, the username is Elastic, and we'll have to copy the password from here. So this is the auto-generated password. Here we can now access the Elasticsearch instance. Also, this has been enabled on HTTPS. So if we go back to the folder, and here in the config folder, certs folder gets generated, and these are the certificates being used for SSL. Next, we do not want to make use of the auto-generated password. We want to regenerate our own password for this Elastic user. So for this, the command is Elasticsearch reset password -u Elastic, that is for the user Elastic -interactive. So in the interactive mode, we'll be resetting the password. So copy this command. Also, Elasticsearch cluster, it is still running. So keep it running. Go to the folder, and here again start a new command prompt and use this command here. Press Y, and here enter the password for Elastic. So I'll be setting the password as Java use. Re-enter the password. So the password has been successfully reset. So now that the Elasticsearch instance is up and running, we'll begin with the Spring Boot implementation part. For this, we'll be creating the Spring Boot application using the Spring Initializer website. So go to this website here. We'll be creating a Maven project. I'll select the version as 3.2.6 for Spring Boot application. The group will be com.javanews. Artifact, give it as boot Elasticsearch CRUD. Next, we'll be adding the dependencies. So the first dependency, the Spring Web dependency. Next, we'll be adding the Elasticsearch data dependency. So these are the only dependencies that we'll be adding using Spring Initializer. Click on generate. This will download the Maven project. Here I have imported the Maven project in Eclipse. Go to Elasticsearch CRUD. Right click on the pom.xml, run as Maven install. So this will download the dependencies that we have specified in the pom.xml. So these dependencies are Spring Boot Starter Data, Elasticsearch dependency, and the Spring Boot Starter Web dependency. So here the build is successful. Next, in the pom.xml, we'll be adding some more dependencies. So the dependencies that we'll be adding are the Elasticsearch Java dependency and the Jackson Databind dependency. So in a pom.xml, we already have the Spring Boot Starter Data Elasticsearch dependency. Then why do we need this Elasticsearch Java dependency? So this Elasticsearch Java dependency, it is used to include the official Java client for Elasticsearch in our project. So the Spring Data Elasticsearch, it makes use of this Elasticsearch Java dependency to establish a connection with Elasticsearch and perform the CRUD operations. So the Spring Data Elasticsearch, it provides a higher level abstraction over the lower level Elasticsearch Java so that we can work with Elasticsearch using the familiar Spring Boot repositories and patterns. Next, in the pom.xml, we'll be adding these dependencies. So copy this and here add them in the form.xml. I'll again build this project, run as maven install. Previously, we have seen that when we start Elasticsearch, by default, it runs on HTTPS. So for a Spring Boot application to connect to this Elasticsearch instance on HTTPS, we'll need to create a trustor file. So this trustor file, it is then used by Spring Boot application to establish a secure SSL TLS connection with the Elasticsearch cluster. In this trustor, we'll be importing the CS certificate of Elasticsearch. So when our application it attempts to connect to Elasticsearch, it will make use of this CS certificate in the trustor to verify the identity of the Elasticsearch server and establish a trusted connection. So go to this Elasticsearch JDK bin installation and run the following command. So the command is key-to-exe import file. So here we'll be importing the HTTP CSCert of Elasticsearch. We'll be creating a key store. The name of this will be trustor.p12, and for this key store we'll be giving the password as Java in use. When we started the Elasticsearch instance, the Elasticsearch in the config folder certs, by default it created these certificates. So we'll be importing this HTTP CSCert in the trustor. So copy this command, go to the JDK folder, bin, and here use this command. Here it is showing that certificate was added. See, now go to the cert folder. Here the trustor has been created for us. Next, in a Spring Boot application, we'll be creating a class named HTTP client config INPL, which implements the HTTP client config callback. So using this interface, we'll be configuring the HTTP async client builder, using which we'll be establishing a connection to the Elasticsearch instance. So previously when we started Elasticsearch, we had set the credentials for Elasticsearch instance. So the username it was Elastic and the password it was Java in use. So these credentials we are providing to this HTTP async client builder instance. Also previously we have created a trustor at this location. So next, using the SSL context builder, we'll be loading this trustor. So here along with the trustor, we also provide the password that we have configured for this trustor. And this SSL context is then again provided to the HTTP client builder, using which it will be establishing a connection to the Elasticsearch instance. So let us create this class. Go to Elasticsearch source main Java. Here create a new class. Package will be com.java near Spring Boot Elasticsearch CRUD.config. Copy the contents of this class. So the HTTP client config INPL class that we just created, using this we can establish a secure and authenticated connection with the Elasticsearch cluster. However, to fully integrate Elasticsearch into a Spring Boot application, we'll need to create a bean that encapsulates the client configuration and provides an instance of the Elasticsearch client class. So here we'll be creating a new class named ESClient, and for this we'll be making use of the component annotation. In this class, we'll be creating a bean of type Elasticsearch client. In this method, using the REST client builder, we create an instance of the REST client. So our Elasticsearch instance, it is running on localhost 9200 and on HTTPS. So we provide this to the REST client builder. To the REST client builder, we also provide an instance of the HTTP client config INPL class that we just created. So using this, it can create a secure connection to the Elasticsearch instance. So once we get the REST client, we create a new instance of REST client transport, to which we pass the REST client and also the Jackson JSON mapper, which is used for handling JSON serialization and deserialization. And finally, we create an instance of the Elasticsearch client, to which we pass the REST client transport instance. So let us create this class. In Eclipse, create a new class in config package. Copy the contents of this class. Next, we'll be creating a document class named employee. So this is the class which will map the employee data to the Elasticsearch index named employee. So here we have the class named employee, and we are making use of the document annotation to tell that this data it should be mapped to the indexed employee in the Elasticsearch instance. This class it has the fields ID, name and department. So here for ID we have made use of the ID annotation, which tells that this will be unique for each record, and we have the default constructor and the overloaded constructor here. So let us create this class. Here create a new class employee, package into .model. Copy the contents of this class. In data Elasticsearch, it provides a convenient way for us to interact with Elasticsearch by leveraging the repository pattern. So by defining an interface that extends Elasticsearch repository, Spring Data Elasticsearch, it automatically generates an implementation for the common CRUD operations and also custom queries on Elasticsearch documents. So here we'll be creating an employee repository that extends the Elasticsearch repository. To this we pass two parameters. The first is the entity class employee that we just created, and the other is a string. The second parameter is string because for this employee entity, the ID that we have defined, it is of type string. So we define the second parameter as string. So let us create a new interface named employee repository. create a new interface. Package will be repository with the contents from here. So let us start Elasticsearch instance. So for this, go to the Elasticsearch bin folder and start elasticsearch.bat. So this will start the instance. Here the Elasticsearch instance, it has started. So if you go to this URL https localhost 9200 _cat indices $v. So this will show us all the indices that are present for this Elasticsearch instance. So we have set the username as Elastic. Password we have set it as Java use. Sign in. So here we can see that currently there are no indices present. Next we'll be starting our Elasticsearch instance. So for this, right click on this class which has the main method and run as Java application. So here it is showing that our Elasticsearch, it has started successfully on port 8080. Next, again go to this URL which has the indices. Refresh this, and here we can see that our index named employee has been created for us. So here for the employee class, we had specified the index as employee. So the employee repository created an index named employee for us. The employee index that just got created, currently it has no documents or records. Next, using the REST controller, we'll be exposing a post endpoint. So the user, he can make a call to this post endpoint with the employee object, which will then get inserted in this employee index. Using the REST controller, we'll be exposing a post endpoint with the URL /employee. So the user, he will make a call to this post endpoint, and in the body, he will be sending the employee object, which is to be saved in the index. The REST controller will then make a call to the service layer and pass it the employee object that it has received. The service layer will then make use of the DAO layer. The DAO layer is nothing but the employee repository that we just created, and the employee repository will then persist that object in the Elastic instance. Next, we'll be creating the employee DTO class. So DTO, it stands for data transfer object. It allows for a clear separation between the presentation layer, that is the web layer, and the domain layer, that is the service layer. So DTOs, they provide a way to transfer data between different layers, such as the controller and the service layers. So at the controller level, we'll be making use of the employee DTO class. So when the user, he sends a post request, an object of employee DTO will be created. But when performing some logic at the service or at the DAO layer, we make use of the entity class, that is the employee class that we have created previously. The employee DTO class, it will be having the same fields as the employee class, that is ID, name and department. And also here it has no Elasticsearch or other annotations, as we are just using it for the presentation layer to receive the data from the user and return it back. So let us create this class. Create a new class here in model, employee DTO, finish. Copy the contents of this class. At the service layer, we need to convert this employee DTO instance to employee instance and vice versa, and we need to perform this operation many times. So for this, we'll be writing a new class named employee mapper. This employee mapper, it has two methods. So one takes the employee instance and returns back an employee DTO instance. The other, it takes an employee DTO instance and returns back an employee instance. So let us create this employee mapper class. Go to Eclipse. In Eclipse, create a new class. Package will be mapper. Copy the contents. Next, we'll be creating the service layer. So for this, we'll be creating an interface named employee service, which has a single method named create employee. This create employee method, it will be called by the REST controller to create a new employee instance. So for this, the employee DTO will be passed by the REST controller. This employee DTO will then be converted to an employee object, and it will be persisted in the Elasticsearch instance. So once persisted, then this employee object, it will be converted back to the employee DTO instance and returned back to the controller and then again to the user. So let us have a look at this employee service implementation. So here we'll be creating a class named employee service IMPL, which implements the employee service interface. And also for this employee service IMPL, we are making use of the service annotation. In this class, we have auto-wired the employee repository that we created previously. So here we are overriding the create employee method. So once the create employee method gets called by the controller, it gets the employee DTO instance. Next, using the employee mapper, we convert this employee DTO object to an employee instance. And then this employee object, it is passed to the same method of the employee repository, so that it gets persisted in the Elasticsearch instance. The employee repository then returns back an instance of the employee object, which is persisted in the Elasticsearch instance. Next, using the employee mapper, we convert this created employee object, which is of type employee, to employee DTO instance and return it back to the controller. So let us create this employee service interface and its implementation. Go to Eclipse, create a new class, a new interface. Package will be service. Okay, this. Next, we'll create the employee service IMPL class. Copy this content. Finally, we'll be creating the controller implementation. So here we are creating a controller class named employee controller, for which we make use of the REST controller annotation. In this class, we have auto-wired the employee service interface that we just created. So here we have exposed a post mapping with the URL /employee. So here for the create employee method, we take a request body as employee DTO object. So this employee DTO object is then passed to the create employee method of the employee service, and it returns us back the employee DTO object that is persisted in Elasticsearch instance. which is returned back to the user. So let us create this class. In Eclipse, create a new class. Package will be controller. Copy the contents of this class. So for the create employee API, we are done with all the coding changes. Let us now test these changes. So I'll be starting the Spring Boot application in debug mode. So here I'll be adding a debug point. So let us start this in debug mode, debug as Java application. So here the application it has successfully started. Next we'll be making the actual post call to localhost 8080/employee. And here in the body, we are passing the details of the employee that we want to be persisted in the Elasticsearch instance. So the name is employee1, department is marketing. So I'll click on this. Here in Eclipse, we have received this request. So in the employee DT object, the department is marketing, name is employee1. We have not passed the ID. So this ID, it will be generated when this employee object is persisted in the Elasticsearch instance. That time this ID will be generated and it will be returned back. Next, let us add a debug point in the employee service implementation. So here now we are inside the employee service. So this employee DT object, it is converted to an employee object. Next, we call the same method of the employee repository. This will persist the employee object in the Elasticsearch instance. So here we got back the created employee. So if you'll check here, the department is marketing and name is employee1, and this is the ID that has been generated in the Elasticsearch instance for this particular employee. So let us return back these details to the employee. So here the user, he gets back these details. In the browser previously we had checked that for this index employee, the docs count it was 0. So let us refresh this. So now we can see the doc count is 1. So here go to employee /_search, pretty print. So this will give us the details of the employee record that has got inserted in this employee index. Next we'll be implementing the employee ID by API for a Spring Boot application. So here in the REST controller, we'll be exposing a REST endpoint with the URL /employee/ID. The ID is the employee ID of the object that is to be retrieved from the Elasticsearch instance. So here the REST controller, once it gets the ID, it passes it to the service layer. The service layer then makes use of the DAO, that is the employee repository that we have created. And using this, we retrieve the employee details for this particular ID from the Elasticsearch instance and return it back to the service. So when the service receives this employee details, it is in the form of the employee instance. So this employee instance is converted to employee DTO instance and returned back to the controller, which then returns it back to the user. Let us begin with this implementation part. First, we'll be creating the employee not found exception class. So suppose if the user is trying to retrieve an employee with a particular ID which does not exist in this Elasticsearch instance, in such a scenario, we'll be throwing this employee not found exception. So let us create this. So here in Eclipse, we'll be creating a new class. Package will be exception. Next, inside the employee service interface, we'll be creating a new method named getEmployeeById, which will be passing the employee ID for which the employee object is to be retrieved from the Elasticsearch instance. So this employee DT object, it will be returned back to the user. Also this method, it throws the employee not found exception. So this will be in a scenario where the employee details corresponding to this employee ID, they do not exist in the Elasticsearch instance. So copy this. Here go to the employee service and add this method. If you now go to the employee service IMPL class which implements this employee service, it will ask us to override this method. So add unimplemented methods. Let us have a look at this implementation. So the employee controller, it will be calling the getEmployeeById method of the employee service IMPL, to which it will be passing the employee ID of which the employee object is to be retrieved from the Elasticsearch instance. In the getEmployeeById method, we make use of this findById method of the employee repository, to which we'll be passing the employee ID. So this retrieves us the employee object corresponding to this employee ID, and this employee object, it is of type optional. If this optional is empty, it means that corresponding to this employee ID, no employee details are found in the Elasticsearch instance. If it is not empty, then we convert this employee instance to employee DTO instance and return it back to the controller. Copy this, paste it here. Next, we'll be adding the getEmployeeById method in the employee controller. So here we'll be creating a new method named getEmployeeById. The URL is /employee, and in the URL we'll be passing the employee ID, which we retrieve it using the path variable annotation. So here we get the employee ID. Then inside this getEmployeeById method, we make a call to the employee service.getEmployeeById method, to which we pass the employee ID, and this returns us back the employee details corresponding to this employee ID. Copy this, go to the controller class. We are done with all the coding changes. Let us now test these changes. So run a Java application. Here the application, it has started. We'll now try to retrieve this employee object that we had inserted earlier. The ID was this. So copy this. We'll be making a call to localhost 8080/employee/ the ID which is to be retrieved. So here we are getting the details corresponding to this ID. So here the get employee by ID API, it is working properly. Next, for the Spring Boot application, we'll be implementing the get all employees API. So in the employee service interface, we'll be adding a method get employees, which returns us back the list of employee DTO. Copy this, go to employee service, and here add this method. If you go to the employee service IMPL, it will give an error asking to add the unimplemented method. So here we'll have to give the details of the get employees method here. In the get employees method, we'll be calling the find all method of the employee repository. So this returns us back all the employees from the Elasticsearch, but instead of returning it as a list of employees, it returns back iterable employees. So we'll need to convert this iterable to list. So we do this using Java 8 stream support. So then we get a list of employees. So finally, again using Java 8 stream method, we call the employee mapper.map to employee DTO method and convert this list of employee to list of employee DTO and return it back to the controller. Copy this. Finally, in the employee controller class, we'll be creating a new method named getEmployees with the URL /employees. So in this method, we'll be making a call to the getEmployees method of the employee service, which will return us the list of all the employees, and this will then be returned back to the user. For the employee controller, let us add this. Go to the controller. So we are done with the changes for the get all employees API. Let us test these changes to start the Spring Boot application and the Java application. Here the application it has started on port 8080. So previously we had this get API, employees, hit this. So currently we have only one employee record in the employee index. So let us create multiple. Now let us test the get all employees. So here it is fetching us the list of employees from the Elasticsearch database. Next, for the Spring Boot application, we'll be implementing a delete employee by ID API so that we can delete a document corresponding to this particular ID from Elasticsearch. In the controller class, we'll be exposing a delete mapping with the URL /employee and the ID of the employee that is to be deleted. So the user making this URL, he'll be making a call to the REST controller. The REST controller will then pass this ID which is to be deleted to the service. The service will then make use of the DAO, that is the employee repository, to delete this particular document corresponding to this ID from Elasticsearch. So let us begin with the implementation part. So in the employee service, will be adding a method delete employee to which we pass the employee ID which is to be deleted from Elasticsearch. Also this method throws employee not found exception. So if no employee corresponding to this employee ID is found, then this exception will be thrown. Copy this. In Eclipse, go to employee service and add this here. Now if you go to the employee service IMPL class which implements the employee service interface, here it will give an exception. You have to add the unimplemented method for the delete employee. Let us have a look at the logic that we'll be adding for this delete employee. So in the delete employee method, we get the employee ID which is to be deleted from Elasticsearch. So first what we do is, by making a call to the find by ID method of the employee repository, we first check if the employee corresponding to this employee ID it exists in Elasticsearch or not. If it does not exist, then we throw this employee not found exception. If it exists, then we make a call to the delete by ID method of employee repository to which we pass the employee ID and delete this record from the Elasticsearch index. So copy this method and add it here. Next, we'll be modifying the employee controller to add the delete employees method. So the URL for this is /employee/employee ID. So in the path variable, we get this employee ID which is passed in the URL. Inside this method, we make a call to the delete employee method of the employee service to which we pass the employee ID corresponding to which the employee details are to be deleted from Elasticsearch. So copy this, go to the controller and add this here. So let us test this delete employee API, start the Spring Boot application. Here the application it has started. So here the URL will be /employee/ the ID which is to be deleted. So suppose if I am deleting this second ID, and this will be a delete mapping, so select delete. Okay, now suppose if I again do get employees. So previously we were getting 3 records, now we are getting only 2 records. For a document, it has been deleted from the Elasticsearch index. Finally, we'll be implementing the update employee API for the Spring Boot application. So using this API, the user he can update the user details that are stored in the Elasticsearch for an existing user. For this, in the controller class, we'll be exposing a put API. So the user he will be making a call to localhost 8080/employee, and in the body he will be passing the employee details which are to be updated. Once the controller gets these employee details, he will be passing these details to the service. The service then makes use of the DAO, that is the employee repository, to update employee details in Elasticsearch. Let us begin with the implementation part. In the employee service, add this method update employee to which we pass the employee details which is to be updated. And once this employee details it has been updated, it will be returned back to the user. Go to employee service. If you now go to the employee service INPL class, which implements the employee service interface, you get an exception here. You need to add the unimplemented method. So here we'll need to write the logic for the update employee method. So in the employee service INPL, we will be having the update employee method to which we pass the employee DTO. So the employee DTO, it contains the details of the employee which is to be updated in Elasticsearch. So similar to what we did in the delete employee method, in the update employee method, we make use of the find by ID method of the employee repository to check if the employee corresponding to this particular ID that is there in the employee DTO, it exists or not. So if it does not exist in Elasticsearch, then we throw the employee not found exception. If it exists, then we update the details of this employee and save it again to Elasticsearch using the save method of the employee repository, and the saved employee is then returned back to the user. So let us implement this. Copy this. And then we will be modifying the employee controller. So here we'll be adding the method named update employee with the put mapping and URL/employee. For this method, in the body we'll be receiving the employee details which are to be updated. In this method, we'll be making a call to the update employee method of the employee service, to which we'll be passing the employee details which are to be updated. So once these are updated, the updated employee will be returned back, and this will be returning it back to the user. So let us implement this. Go to the controller class. So we are done with the changes for the update employee API. Let us now test these changes. So run as Java application. So this will start the application. So here the application it has started. If you now go back here, see now run this /employees. Here we have 2 employees. So next, copy one of these employee details. We want a put mapping. So this employee 3, the department, instead of IT, I'll be changing it to admin. Let us test this. So here it has been returned back. So if you now go back to get employees, and if currently it is IT here, let us run this. So here now it is returning it as admin. So the details, it has been successfully updated in Elasticsearch. If you have understood this tutorial, you can download the source code from here. Thank you.